There's a little car going around the racetrack, and it slows down a little bit in the curves, but then it keeps going, and it's going fine, and it slows down just a pinch. It's an old car. It's an old racetrack. The question I have for you is its velocity always the same? Is its speed always the same? Ignoring the fact that it's an old car and it has to slow down for the turns. But let's take a look at this. Velocity and speed. Well, what's the difference between velocity and speed? If we take a look at our formulas here, I mean, they both have a delta D over delta T, which, by the way, what is delta D over delta T? Let's take a look at that. Delta D means change in distance. So this will be the final distance minus the initial distance. Delta T means a change in time. That would be the final time minus the initial time. And it would look the same down here, except that we're ignoring something. What are we ignoring? Well, we're ignoring the fact that there is this little arrow right here. That doesn't happen in speed. So that means over here, we have to have an arrow. We're not talking about distance, we're talking about displacement. Displacement includes direction. It's a vector. Remember that arrow means vector. So the difference between velocity and speed is that velocity is the change in displacement over time. It includes direction. It is a vector, whereas speed is just the change in distance over time. It does not include a vector. So let's go back and look at the car again. Well, there goes the car around the track. Let's take a look at its velocity vector. Right here, the car is going straight. So its velocity vector is going straight. If you go farther down here, the car is still going straight, kind of following what the track is doing. Over here, if we follow the track, it's going this way. Over here, follow the track, it's going that way. Over here. So if we take a look at the velocity vectors as it goes around the track, we can see that in the straightaways, it's going straight all the time, and the velocity vector is the same. So the velocity in the straightaways is the same. But if we look at it at the edges, we can see that the velocity vectors aren't the same. They've changed direction. Therefore, velocity is changed. Velocity changes when you go around a curve, or when you change direction. It also changes when you change speed. Speed has no vector. So let's take a look at that for a minute. If we take a look at the speeds, we can see there's a couple of places where the car had to slow down. Right over here it hesitates for a minute, and right over here it hesitates for a minute. But other than that, the speed is always 2 meters per second. So the speed is relatively constant, even when the velocity is changing. And that is the difference between speed and velocity. Taking one more look at it, we could see we would have some strange things happening, just like we did with displacement. If you go 30 miles per hour that direction for a certain time, say 2 seconds, and then you go 30 miles per hour this direction for 2 seconds, you could find out that your displacement is 0 because you end up right back where you started from. Therefore, your velocity is 0, even though you knew you were traveling. There's that paradox, or what feels like a paradox to us, that happens. We don't see it very often unless you're on a circular track. Speed, on the other hand, doesn't matter whether you're going east or west. So in this case, it would always be 30 miles per hour. We tend to use the words velocity and speed interchangeably in our everyday language. But especially in this chapter, it makes a big difference. You have to be careful which one you're talking about. And thank you very much.